Hey there, this is Chipmunk Math, I'm Vince, and in this video we're going to do a quick review of the Pythagorean Theorem. So, what's the Pythagorean Theorem? For any right triangle, a squared plus b squared equals c squared. What do those letters mean? Well, C, let's start with that one, that's the hypotenuse, the side that's opposite to the right angle, and that's always the longest side in your right triangle. As for A and B, they're just the other two sides that aren't the hypotenuse. Notice this theorem can only be used for right triangles. If you're looking at something that does not have a 90-degree corner, you cannot use the theorem. It's tempting to try to use it on any triangle, but it's gotta be a right triangle if you're using a squared plus b squared equals c squared. Finally, memorize this thing. Seriously, it just keeps coming up. It's really useful to have it memorized if you haven't memorized yet. I would really recommend memorizing it. So how do you use the Pythagorean theorem? You use it to find unknown sides on right triangles. You set up using the equation, then you solve. So for example, say we've got this triangle here, right? How would we figure out what that value for y is? Well, we know a squared plus b squared equals c squared, right? We're looking at a right triangle, so we can use a squared plus b squared equals c squared. Which one is your hypotenuse? The longest side there's 19. That's the one opposite the right angle. So we plug that in for c, the other two in for a and b, and now we've got 15 squared plus y squared equals 19 squared. And at this point, it's just a matter of doing algebra, right? We can figure out what y is with a little bit of simplification in algebra. If you're dealing with something a little bit more complicated as for the expression, right, it's something that's not just a number or not just a single letter, then you want to make sure to plug in using parentheses. So if we're looking at this triangle, right, we're going to use a squared plus b squared equals c squared again, but it's tempting to say, oh, I'm going to plug in z plus 1 squared for my z plus 1 leg, plus 4, my other leg, squared, equals z plus 3, the hypotenuse, squared. But if you plug it in like this, you're not dealing with the fact that z plus 1 is the entire side, so that entire side needs to be squared. Same, z plus 3 is your entire hypotenuse, so all of z plus 3 needs to be squared, right? What you're doing there is you're only squaring part of it. So what you need to do instead is you need to make sure to plug in with parentheses. So it's z plus 1 is a quantity being squared, plus 4 squared equals z plus 3 is a quantity being squared. And then from there, once again, it's just a matter of simplification and algebra to figure out what your z value will be. The Pythagorean theorem also works in reverse. We call this the converse of the Pythagorean theorem. So what I mean by that is if you have the fact that a squared plus b squared equals c squared for some triangle, right? You can set up that equation and it holds true. And now c doesn't actually mean the hypotenuse now, it just means the longest side because you aren't certain that it's a hypotenuse yet. If a squared plus b squared is actually equal to c squared, then you're looking at a right triangle. So for example, say we've got this triangle here, right? We've got two legs of 3 and 4. The two shorter sides are 3 and 4, and our hypotenuse is 5, right? Because, well, maybe it's a hypotenuse, maybe it's not a hypotenuse, we don't know yet, but the longest side is 5, so we'll call that our c value. We set up, is 4 squared plus 3 squared equal to 5 squared? We don't know yet, let's find out. 4 squared is 16, 3 squared is 9, 5 squared is 25. So what's 16 plus 9? 16 plus 9, 25 is equal to 25, so that means that our equation from the beginning, 4 squared plus 3 squared, was equal to 5 squared, so that means we are looking at a right triangle, and that's how you use the converse of the Pythagorean theorem. Finally, when three whole numbers work in a squared plus b squared equals c squared, right? The numbers that we're plugging into that equation are all whole round numbers. We call it a Pythagorean triple. And you just saw that when we were looking at that 3 squared plus 4 squared equals 5 squared, right? When we had 4 squared plus 3 squared equals 5 squared, we were seeing a Pythagorean triple because they're all whole round numbers. Now, triples give clean answers. These Pythagorean triples are nice round numbers, and so they often show up on tests, especially on standardized tests like the kind that you take for college admissions. So memorizing a few of these Pythagorean triples can help give you an edge when they show up on tests. I'd recommend memorizing the most common triples, which are 3, 4, 5, 5, 12, 13, and 8, 15, 17. Additionally, you can find more information about Pythagorean triples in the extra video, Extra Pythagorean Triples. We go into more detail, talk about more of the triples and how this stuff comes up. All right, that wraps things up. Thanks for watching. If you want any more detail on any of these things, check out the other videos on this topic at chipmunkmath.com. See you next time.